Okay, so find the area under this curve using the limit process. A quick sketch always helps. 81 minus x squared looks like that. But we're going to start this one at 1, which makes it a little more difficult. Go to 4. Okay, I put all the formulas here. There's your 4 formulas. Then we're going to probably need a couple of these for this problem. The process is the same for all of these. We want to find the limit. The area is the limit as n goes to infinity of our sum s of n, where s of n is each of the heights of each rectangle, which we get by the function, times the width of each of these guys, each of these little subintervals, okay? So this is given by the width of the interval, which is 3, divided into n equal parts, okay? So delta x is just 3 over n. And then the c sub I is a little tricky. Like if we started at 0, it would just be 3 over n times I, right? And then at I1, I2, I3, I4, it just moves through the interval starting at 0. However, we want to start at 1, but the shift isn't that bad. We're just going to add 1 to it, right? So if we just say 1 plus that, then we start at 1 and use the same concept. We just let I be 1, and then it just moves through this interval as I goes 1, 2, 3, 4, and so on. Okay, so there's a little formula for that. It would just be A, right, which is the beginning of your interval, plus the delta x times I. Okay, so that means S of n, we'll come back to the area. We're just got to do a lot of algebra here to find S of n. That's going to be my function evaluated at 1 plus 3 over n times I. So that's 81 minus x squared, where x is 1 plus 3 over n times I. So I got to square that, so be careful with that. And then times delta x, which is 3 over n. Okay, we ready for this? It's going to be an algebra intensive problem. So let's see how we can do with it. So be careful with your algebra. I got to square this out. That's 1 plus 3 over n times I times itself. 1 plus 3 over ni times 1 plus 3 over n times I is equal to 1. And then you're going to get 2 of those terms, right? I'm sorry, 2 of these terms from the O and the I in FOIL. That's 3 over ni and another one of those. That's 2, right? Well, if you FOIL this out, it's 1. And then you get 3 over ni, and then you get another one of those. And then when you square it, you get everything gets squared, 9i squared over n squared. So that's 3 over n plus 3 over n is 6 over n. And then that's going to be 9i squared over n squared times 3 over n times this whole thing, okay? So distribute the negative. 81 minus 1 is 80. I'm going to distribute this negative, and I'm going to run this guy through all at the same time. Okay, so see if you follow me here. That's going to be 80, and then I'll multiply it by 3 over n, so that's 80 times 3 over n. And then minus this term times 3 over n is minus 18 I over n squared. And then this guy gets negative times 3 over n, so that's minus 27 I squared over n cubed. Okay, so now what do I have to do? I got to take the limit as n goes to infinity for that guy, right? Oh, sorry, my sum should have a sum in it. Try that again. Sum as I goes from 1 to n. Okay, so I was missing that. That's important. So now my sum is 240. I'm going to factor out, I'm going to run the sum through. All right, so I'm going to have 3 sums, so I can evaluate them individually when I take the limit, or actually before I take the limit with my formulas. How do I write this guy? Well, that's 240, and I'm always going to factor out the n. In this case, I want I by itself, right? If I want to use my formulas, I want the constant, I want an I squared, and I want an I. We don't have a cube in this one. All right, so I, that means the 18 over n squared is on the outside of that sum, I squared. which means the 27 over n cubed is outside of that sum. Okay, and these are all going I equals 1 to n. Okay, and we still have to take the limit as n goes to infinity, but first we can apply our formulas now. Adding 240 to itself n times is 240 times n. The formula for I is n times n plus 1 over 2. And the formula for I squared is, make sure I got that one right, n times n plus 1 times 2n plus 1 over 6. N times n plus 1 times 2n plus 1 over 6. Okay, that's my S of n. Now I can take the limit to get the area. I want the limit of this thing as n goes to infinity. Okay, so let's do a little bit more algebra. That's going to be 240 as n goes to infinity, just stays 240. This one will reduce to 9, 2 into 2 once, and 18 9 times. So let's see, the limit as n goes to infinity of 240 minus, let's factor out that constant 9, and then group our n term together, n times n plus 1 over n squared. And then how about this guy? Let's factor out the constant 27 over 6, and then the n terms together, so we can take the limit as n goes to infinity. Okay, oh, n cubed. All right, so what does this do as n goes to infinity? That goes to 1, right? If we run that through, we get an n squared plus n, leading coefficients. So I'm going to take the limit now. That's the limit of a constant is just the constant. The limit of this thing is just 9 because the limit of this is 1. And then what happens with this guy? Well, this is cubic, right? N times 2n is 2n cubed. I could FOIL that out if I want to, but I only have to focus on the first term. It should be n times 2n cubed, 2n cubed plus whatever, doesn't matter, because at infinity, all I care about is that, right? The leading terms of the numerator and denominator. So I get the constant that comes along for the ride, and then this should be 2n cubed over n cubed as n goes to infinity is 2. So that's a minus. And now we've evaluated the limit, and we are just about done. 240 minus 9 minus, what is this? This would be a third, right? 2/6 is 1/3. 9, so 240 minus 18, 222.